This is a supplement I wanted to make to our video on symmetry, or our lesson on symmetry. I'm going to show you in a computer-aided design program called Onshape some of the ideas of symmetry that we're talking about, particularly three-dimensional ones. So in a computer-aided design program, generally you start by making a two-dimensional sketch, and then you can create that into a three-dimensional object with various operations. So I wanted to start off in 2D, so I'm going to make a sketch where I can draw on a flat plane. Right now I'm in this three-dimensional space, and I'm going to work only on this top plane right here. So I'm going to change my view so that we're looking straight at this plane and not really seeing the rest of our three-dimensional space. And I want to make a couple of things. So if I take a shape, let's say I take a rectangle, and I wanted to create some make it basically have a line of symmetry and make this, half of the shape, like half of a symmetric shape. I can use an operation called mirroring, which is just like a reflection. So I have this mirror icon here, and I can pick to mirror over any line. So I could pick this side of the rectangle, and then pick all of these lines to mirror, and now I end up with basically that mirror line I created as a line of symmetry. Not that interesting. I could have just drawn a bigger rectangle. Would be more interesting if we did a different kind of shape, so something like this maybe. I'll close that, and then if I mirror that over this line, I'm going to mirror all of these lines, then we end up with a shape that has bilateral symmetry. And a lot of times that's a good thing in design because you want something to be the same on the left and the right. So I can easily mirror that, and the cool thing about that is it maintains symmetry between these even if I change my original shape. So if I change this one to make this wider or narrower, then instead of having to make the same changes on the other side, I take advantage of that symmetry in that it's going to keep this shape symmetric no matter how I change the one side, the other changes to match. If I had drawn this whole shape, I would have to go and change the left side and the right side independently. So this basically cuts that work in half. If I want to change something about the profile, both sides change together. So that's really useful. So the fidget star I have in my room, so those ones that are collapsible stars, if I take this shape, then this is actually all of a shape I need to make the outline of that fidget star because it has rotational symmetry. So if I need to put a couple of constraints on this, so let me make some construction lines here. And what I want is to end up with an 8-pointed star. The 8-pointed star is going to have an order of symmetry, rotational symmetry, of 8. So I'm going to need this angle here to be 135, and I'm going to need this angle to be 45, because if you remember order and magnitude, with an order of 8, I have a magnitude of symmetry of 45. So I'm going to take this shape and rotate it 8 times and make it basically pattern all the way around. I also need these two lines to be equal, so I'm going to force them to be equal in length. Okay, so that's it. This is the star design. All I need to do is use a tool here called Circular Pattern, which is going to let me pick some objects. And then I specify here, it says 3 times, so it's making 3 of those, but I want an order of symmetry of 8. So I'm going to have it make 8 instances, basically 8 copies, to where it's going to go all the way around. And then this should look familiar from the toy box in my room of the fidget stars that I have. So now the nice thing, just like with the bilateral symmetry, if I want to change something, notice I didn't tell it how big to be. So I told it these to be equal, but I didn't tell it how far from the center this should be. So I could make a bigger or a smaller fidget star, and all of the dimensions of it will adjust if I just change one dimension. So I can reshape the entire thing just by moving this point closer or further from the center and changing basically that radius of the circumscribed circle that we could draw around this. So I end up with this 8-order symmetry, and it makes changing this design super easy. So you may have seen I have different sizes of these fidget stars, and it's really simple to change from one size to another because all I really need to do is define the height of this line right here. So if I make it 25 millimeters or 50 millimeters, it's going to make the star bigger or smaller. So that radial symmetry, rotational symmetry, I guess, in 2D, the rotational symmetry, where I'm just taking these two lines and patterning them, makes the work a lot easier. So instead of changing the distance of every corner from the center, I just have this one dimension that drives the entire thing. So that's a good example of rotational symmetry, I think. Let's look at some of the 3D symmetries that we talked about. So let me delete this guy. And we're going to start over. I'm going to bring back my three-dimensional principal planes. So going into a three-dimensional space, I want to see an example of a plane of symmetry. So on this front plane, I'm going to make a sketch. Since I'm drawing a flat thing, I'm still going to go ahead and look straight at it and see this here. I'm going to make a shape like the one we saw in the notes. So we had kind of a Tetris-y looking piece. And this, if you know the cube puzzles I have in my room, where it's like 5 pieces that together make a 3 by 3 by 3 cube, this is the exact process that I make those shapes by. So I make an outline or a profile in 2 dimensions, and then we're going to use what's called an extrude. So extrude pushes a shape into 3 dimensions, and it does it kind of uniformly. So it's going to push it into 3 dimensions to where it's going to have a plane of symmetry at half that distance. I can even create it instead of coming out of that front plane uniformly in one direction. I have an option here for a symmetric extrude. What that does is it forces the plane I drew the sketch on to be the plane of symmetry. So instead of coming away from that plane, if I click this one, it will make that front plane the plane of symmetry, and it will extrude it in each direction the same distance. So I end up with kind of this front and back piece that are congruent because that plane of symmetry is right down the middle. So that's an example of a plane of symmetry. We use it with this extrude operation in order to make shapes that are, I think of it like a Play-Doh press, if you had one when you were little, where you push the Play-Doh through and it has a 2-dimensional cutout, and everything that squishes out through there is kind of like the same cross-section. All right, so let's do one more thing and look at axial symmetry or radial symmetry. So just like the extrude, I'm going to start by sketching a profile. So I'm going to sketch on this front plane, but this time I'm going to start by drawing an axis of symmetry that we can revolve a sketch around. So instead of pushing that shape through a window and making it come into the 3rd dimension, I'm going to take a shape here and close that. And I'm going to use a tool called Revolve. So I'm going to take this triangle, and in 3 dimensions, I'm going to spin it around this axis. So I'm going to revolve. I pick what I want to revolve. That's already selected. And I pick my axis I want to spin around. So that's going to take that triangle and rotate it around so that I end up with a shape that has this axis of symmetry, and kind of like we talked about in the notes, it would have infinite planes of symmetry I could cut through this, but it spins the triangle around there. And by changing where that axis of symmetry is, I can change what it looks like. So if I make the revolve axis, well, let me draw a different one. If I make the revolve axis closer to the triangle, for example, then I'm going to end up with a different shape. I'm going to make that visible. We'll pick this as the axis, and we'll hide this first revolve. So you can see the 2 shapes, yeah. So I end up with a much smaller hole in the middle because I revolved the shape around an axis much closer to the triangle. In fact, if I revolve it around one of its own lines, I'll end up with no hole in the middle, and it'll be a solid revolved shape. So let's revolve this triangle around one of its edges. And what I end up with is a shape here. Let me hide all of these. That is a solid shape that has an axis of symmetry through the middle, and its cross-section is this triangle that I drew. So in engineering, we use revolves to make all kinds of shapes with axial symmetry, particularly in like the oil and gas industry, We use flanges to connect parts to each other, and those are made by revolving shapes. So these are just some examples of how these things look in a computer-aided design environment, and hopefully the examples helped you to kind of visualize how maybe we could take a simple 2D shape and take advantage of these types of symmetry to make more useful, more interesting, more complex things.